Last review for AP Physics 1 is simple harmonic motion. So there are two systems that we talked about. We talked about the simple pendulum, and then we also talked about the spring mass system. The pendulum you did a lab on, and you determined that of mass, amplitude, and length, the only thing that impacted the period was the length. Now we also talked about how gravity would impact it since it is a falling mass. The stronger the gravity, the faster it would fall, making the period smaller. The spring mass system, we did not do a lab, we just did a demonstration, and we found out that gravity actually does not play a role in this. It is all based on the mass, because the mass creates inertia or reluctance to change a state of motion. And K, the spring constant, tells us how tightly coiled that spring is, therefore how hard will it push if it's been compressed, or how hard will it pull if it's been stretched. Now, the equations are fairly plug and chug. They are shown here, 2 pi, and then you have the square root of some stuff. There is one thing I want to highlight that can be a tricky thing, is difference between frequency and period. Well, the truth is they're nearly the same thing. If you know the period, you know the frequency. If you know the frequency, you know the period. Frequency is the amount of cycles completed in 1 second, and period is the amount of seconds required for 1 cycle. So notice that what we did is we took the word cycle and second and we switched them. So the period, t, equals 1 over f, and the frequency, f, equals 1 over t. The last thing to hit on simple harmonic motion is the two various positions. We have a maximum position where your displacement is at its maximum. We have the middle position where the displacement is in the equilibrium. So let's focus first on the position being at the maximum. So delta x is as big as it can get. In this particular case, your mass is at one of the two extremes. It doesn't matter which one. In this position, the acceleration, force, and potential energy are at a maximum, while the velocity, momentum, and kinetic energy are at 0. It is important to note that the total energy never changes. The potential and kinetic energy keep trading off back and forth. When the position is in the middle, or in the equilibrium position, the velocity, kinetic energy, and momentum are maximized. The displacement is 0. The potential energy would ideally be 0. The acceleration / force may not be 0 for the pendulum, but for the spring it would be 0. Once again, your total energy would stay the same. So that force and acceleration for the pendulum, why is that not 0 in the middle? Well, in the middle of the pendulum, you have gravity pulling the mass downwards and tension pulling the mass upwards. The tension has to win. The tension has to be stronger than the force of gravity. Otherwise, the pendulum would not swing upwards. So the acceleration / force of the pendulum is at its minimum in the equilibrium position, but it is not actually 0. That's a wrap.